Hello everyone, I am Rajnish Acharya. So today we will discuss about the timer of 8051. So the agenda in this particular session is to discuss about what are the different timer registers available in 8051 and how to use those timer registers, and then use Keil sessions to see how this timer work in different modes. So 8051 provides two timer registers T0 and T1. They can be operated independently. Now timer T0 and T1, they are 16-bit registers. They are made up of two 8-bit registers. Timer 0 is made up of TH0 and TL0. Timer 1 is made up of TH1 and TL1. Now, in order to operate the timer, we need to control this timer. So there are two control registers provided in 8051 to control the timer registers. They are TMOD and TCON. Now TMOD is called as timer mode control registers and TCON is called as timer control registers. Using TMOD, you set the mode of the timer, and using TCON, you run the timer and check whether the timer has overflown or not. Now let us talk about TMOD register. If you see the TMOD register, there are two nibbles in TMOD registers. The lower nibble corresponds to timer 0 and upper nibble corresponds to timer 1. In the lower nibble, if you see the bits of the lower nibble, there is M1 and M0. This controls the mode of the timers, and you see C/T bar, it controls whether the timer is in the counter mode or in the timer mode, and the gate decides whether the timer has to run using an external pin or whether the timer is run by simply setting TR bit. Now let us talk about the modes of the timers. If there are four modes of the timer, they are mode 0, mode 1, mode 2 and mode 3. Mode 0 is a 13-bit mode, mode 1 is a 16-bit timer mode, mode 2 is the 8-bit auto preload mode, and mode 3 is a 8-bit independent mode. Okay. Now mode 0 is set by setting M1 and M0 as 0 and 0. Mode 1 is set when you set M1 is equal to 0 and M0 is equal to 1. So if it is set as 1 and 0, then it is mode 2, and when it is set as 1 and 1, it is set as mode 3. Now let us go to the next register, that is the TCON registers. The TCON registers, the lower nibble corresponds to the interrupt, which we will discuss in some other session, and the upper nibble is predominantly used to control the run and check whether there is an overflow in the timer. So if you see, TR0 corresponds to run bit of timer 0, and TF0 corresponds to the overflow bit of timer 0. TR1 is the run bit of timer 1 and TF1 is the overflow bit of timer 1. So whenever you want to run timer 0, you have to set the timer TR0, and whenever you want to check whether the timer 0 has overflown, you have to check the bit TF0. I repeat it again. If you want to run the timer 0, you have to set TR0. If you want to check whether T0 has overflown or not, you have to check TF0. Now, so how does each of the timer work? Let us discuss in bit detail. Now you have a crystal frequency, okay, and the crystal frequency is divided by 12 to give you a timer frequency. Now when the C/T bar in TMOD register is set to 0, then the timer is in the timer mode. So whenever the timer is in this mode, the clock frequency is sourced from the crystal. Okay, so that I repeat it again, you have a crystal oscillator, and the crystal oscillator frequency is divided by 12. That gives you the timer frequency. Whenever the C/T bar is set to 0 in TMOD, then the clock frequency is set from the crystal, that is clock divided by crystal frequency divided by 12. But when the C/T bar is set to 1, then the clock frequency is derived by the timer input pins, that is in port 3. So when the C/T bar is 1, the timer is in the counter mode of operation. Now, having discussed about these two clock sources, we'll discuss how does the timer run. Now the timer run switch is controlled by this particular logic gates. Now this is the timer run switch. So whenever the switch is activated, the timer provides the clock to the timer register T0 and T1. Now let us analyze this particular logic gate. Now let us say that the gate is 0. When the gate is 0, the output of the NOT gate is 1, and the output of the OR gate, irrespective of what is the other pin, is always 1. When the output is 1, the TR0 and TR1 bits decides whether the switch has to be activated or not. So when TR0/TR1 is high, the output of the AND gate is 1. So that will connect this particular switch and allow the clock frequency to pass through the next stages. Okay, now when the gate bit is high, at that time the output of the NOT gate is low. Okay, so the output of the OR gate will be high if and only if the interrupt pins in port 3, INT0 and INT1, either one among them, are high. Okay, so the output of the AND gate will be high only if the output of this OR gate or TR0 or TR1 is high. So what it means is, if this switch has to be activated, and if we have to provide the timer clock or the counter clock to the further timer stages, it can be achieved only if both the TR0 is high as well as INT0 is high when the gate bit is high. Okay, so this is called as hardware based control for running the timer. Okay, so let us go to the next topic. Okay, so the timer, we said that there are 4 modes: mode 0, mode 1, mode 2, mode 3. Now let us analyze that mode 0 and mode 2. Mode 0 is a 13-bit mode, and in this particular mode, like in any of the mode, when the timer is operated, it will source the clock from the crystal, and it will be divided by 12, and then it will be sourced to the incrementing of a timer. Now let us see what happens when the timer is operated in mode 0. Okay, I will use the calculator to demonstrate it. And now when the timer is in mode 0, it is a 13-bit mode. So the maximum possible achievable number in the timer register is FF1F. Why is it? Because the TH can be TH is operated in 8-bit mode and TL is operated in a 5-bit mode. So TH in 8-bit mode, the maximum possible value is FF, and TL in 5-bit mode, the maximum possible value is 1F. So FF1F is the maximum possible value. So I will take it as 1F FF. Okay, so 1F FF. So the 1FFF in hexadecimal translates to 8191 in decimal. So if you see, the timer in 13-bit mode will keep incrementing from 0 to 8191. Okay, and once it reaches 8191, if it was initially set to 0, and once it reaches 8191, at that time it will overflow and it will go back to 0, and when it overflows, the overflow flag will be set. Okay, when the timer is operating in mode 1, it is in 16-bit mode. When it is in 16-bit mode, the TH is in 8-bit. 8-bit of TH will be used and 8-bit of TL will be used. So the maximum possible value that can be stored is FFFF. Okay, so maximum possible value in hexadecimal is FFFF. So FFFF in hexadecimal translates to 65,535 in decimal. So the timer will reach till 65,535, and then it will overflow back to 0, and it will keep on counting if the timer is run in the run mode. Okay, and once it overflows, the overflow flag, TF flag, will be set. Okay, coming back to the 8-bit mode, 8-bit, it's also mode 2, 8-bit auto reload mode. What happens in this case is both the timer register TL and TH are used, but they are used in 8-bit mode. So the maximum possible value in mode 2 is FF. So FF translates to 255. So the timer will count from 0 to 255. Once it reaches 255, it will go back to a value that is set in TH0. Okay, I'll repeat it again. When the timer increments and when it goes back, goes above 255, the timer will overflow, but the timer will not be reloaded to 0 by default. It will be reloaded to whatever value is being set in TH register. Okay, so okay, now what we are going to do is we are going to demonstrate the timer using Keil software. Okay, I have opened the Keil software. The version of Keil that I'm using is version 5.5. So if you're using some other versions, there will be some changes in the procedure that you need to follow. Okay, so what we'll do is we'll demonstrate the timer operation using Keil software. So how to use the Keil software? First, in order to use the Keil software, first you have to create a project. Okay, so click on the project menu and click on new microvision project. So you name it as timer underscore sample 1 project and save it. Once you save it, it will ask you what is the type of the microcontroller that you would develop the application for. I'll select AT89C51ED2. Okay, so this is the microcontroller that I will be using. So I will select OK, and it will ask me whether you want to create a startup file. I'll say no. Okay, and the project is created. Now if you see, there is a project name, there is a target, and there is a source group. All the source files, all the files that you will develop, the assembly files or the C files or any other files, will reside in this particular source group. Okay, so the target is something, the microcontroller that you want to develop the executable for, and the project is the composition of all the source files that is intended to a particular target. Now we will right click on the target and click on the options of the target. So we'll change the clock frequency to 11.0592 megahertz and click on the output tab and click on create hex file and press OK. Now the target setting is done, so now we have to add a new file. Okay, so to do that, right click on source group 1 and say add new item to the group. Okay, so you can add a C program or a C++ program or an assembly file or a header file, so on and so forth. Now to demonstrate the timer, we will use an assembly file. So we will click on assembly. Now assembly file will by default be saved as .a51. So I will name the assembly file as timer underscore sample 1. Okay, and then I'll say add. So now it has added this particular file to my source group. Now I am free to write the program in this particular edit window. Okay, so let me start writing the assembly file. I'll start with the directives. Okay, assembly directive. I'll start with the label directive. Okay, name it as start. Okay, so now when you are operating a timer, you have to set the mode of the timer. So so if you see, this particular page gives you a layout of TMOD registers and TCON registers. Okay, so the TMOD registers, now if you are operating timer 0 in mode 0, you have to focus on the lower nibble for timer 0. So if you want the timer 0 in mode 0, then the M1 and M0 bit should be 0 0. So if this is 0 0, and I don't care about what is the timer 1 modes, so I will say that gate 0 is 0 and it's in a timer mode, and it is in mode 0, that is 0 0. So my TMOD value will be 0 0 for timer 0 in mode 0. Okay, let me go back to Keil. So I'll set the mode for the timer. So I'll say move TMOD comma hash 0 0. This represents that the timer is in mode 0. Now mode 0 is a 13-bit mode. So the maximum possible value that the timer can hold is FF1F. So I will load TH0 as FF hash 0 FFH and TL0 as hash 1FH. Okay, so why I am doing this? No, I'll set it as 10H. Okay, so the TH0 is loaded with the FF and TL0 is loaded with 10. So what happens when the timer is run? When the timer is run, the timer will increment. The initial value is FF00. It will increment to FF11, FF12, FF13, so on and so forth. Now that increment depends on what instruction is running. If the instruction that is running is takes one cycle, machine cycle to operate, then it will increment by 1. If it takes more than one cycle to operate, then it will increment by 2 or 3 depending on the type of instruction. Now that we have set the initial value of timer, we will run this timer. So in order to run the timer, we have to use TR0. Okay, so we have to set TR0. So we do it by saying set date TR0. Okay, when the TR0 is set, so the timer will start running. Now the timer has to be monitored till the overflow happens. So the way to do it is we write a loop and we say jump on no bit TF0 again. This instruction will check whether the TF0 is set to 1. If TF0 is 0, then it will loop within itself. Once TF0 becomes 1, it will exit from this loop. Once the overflow happens, it will come out of this particular loop. So what we will do in this particular outside this loop is we will reset the value of timer 0, and we will say that we will clear the value of timer run 0. Okay, CLR TR0. So we will stop the timer, and also we will clear the overflow flag TF0. Okay, and that is the end of the program. So what do you expect in this particular program is the timer will start incrementing in mode 0 from FF10 to FF1F, and it will roll back to 0 0 0 0. Now please remember that J and B jump on no bit instruction is takes 2 machine cycles. So basically what happens is the timer will be incremented by a factor of 2. So let us see this. So we will compile this particular program. So you can say the build target. Okay, so there is a syntax error. Now let us see what is the syntax error. Syntax error is in line 2. Okay, 1 minute. So it's in line 2. So there is a comma that is missing. Okay, now let us save this and let us build the target again. Okay, so now it has compiled successfully and it has created the hex file also. There is no errors or warning. Okay, now we want to run this step by step. In order to run this particular program step by step, we will have to run in a debug mode. So the way to do it is, we will say that start stop debug session. Okay, so when we go to the debug session, it gives you the list of all the registers and the current value that the register holds on the left hand side, and on the right hand side there are two windows. One displays the particular program file, another displays the placement of the program files in the memory location. So we have to monitor the timer register. So that too is the timer 0 registers. Okay, now currently the instruction, the program is not executed and it is pointing to the first line. So if you see the highlighted yellow line, it's nothing but move tmod comma hash 0x00 is nothing but this particular line. Okay, so we will run step by step. So we will run the first line. So whenever we run this, please pay attention to TCON, TMOD, TH0, TL0 and timer run flag and the timer overflow flag. Okay, so the first instruction just sets the timer mode. Okay, so basically TMOD is set to 00, so there is no impact or change in the value of TMOD. Okay, the second instruction set T0 to FF for, okay, the second instruction set T0 to FF. So here TH0, the second instruction sets TH0 to FF. So TH0 should change from 0 to FF. So when I run the next instruction, so the TH0 has changed to FF. Okay, and when I run the next instruction, TL0 has changed to 0x10. Now when I run the next instruction, the timer status currently stopped. When I run the next instruction, it should run the timer. Okay, so I will step over. So if you see, the status of the timer has changed from stop to run. Okay, now so please pay attention. As soon as the timer is run, it has started incrementing the timer. So currently the value of timer is 0xFF1111, 0xFF11. So when I step over, it will increment by a factor of 2 because J and B takes 2 machine cycles to execute. Now if I run it again, it will increment by the factor of 2. So subsequently 17, 19, 1B, 1D, 1F. Now the timer in mode 0, that is the 13-bit mode, has reached the maximum possible value. Now if I run the step once again, so it should reset to 0000 or 0001 and set the overflow flag. Let us see whether it happens. So now I run the step again. So if you see now, timer has changed to 0001 and the overflow flag has been set. Okay, so now we will run further. So it is clearing the timer run flag as well as timer overflow flag. So that is the end of the program. Okay, okay, now let us check about the timer T0 in mode 1. When the timer is in mode 1, T0 M0 is going to be 1 and the rest of the flags are going to be 0. Okay, so when T0 M0 is going to be 1, then the value of TMOD register is going to be 01. Okay, for timer 0. Now if the timer 1 has to be used, and if it has to be used in mode 1, then the value of TMOD is going to be 10. Okay, so now since we are using timer 0 in mode 1, so the value of TMOD is going to be equal to 01. Okay, so now let us go back to Keil and now let us stop this debug session of the previous example. Okay, and I'm going to set timer 0 in mode 1. And in mode 1, the maximum value that can be achievable in the timer is FFFF. So what I'm going to do is I'm going to load 012 TMOD register and FF2 TH0 and F0 to TL0. Now when the timer starts incrementing, it is going to increment from FFF0 till FFFF, and once it reaches FFFF, it will overflow to 0000, and at the same time it will set the TF0 flag. Okay, so now that we have made the changes, so we have to recompile this particular program. So let us recompile it. Okay, there are no errors or warning. Now let us go back to the debug mode and let us run step by step. Now by default the TMOD is equal to 00. Okay, and what has happened is, so since the program has not executed, by default it's in 13-bit mode. Okay, now when we step through or step over after executing the first command, the timer has to change from 13-bit mode to 16-bit mode. Let us see whether that happens. I'll step over. Now if you see here, TMOD has changed from 00 to 01, so that is nothing but timer 0 in 16-bit mode. Okay, and please pay attention to TH0 and TL0. Now when I step over, they will be set to FF and F0. Now timer 0 is not running, so if you see the status is it is stop, and TR0 bit is set to 0. So let us step over. When we step over, it will set the TR0 bit. So I'll step over. Okay, so it has set the TR0 bit and the status of timer 0 is in a run mode. So what happens further is when I execute the J and B, so it has started incrementing from FFF0 to FFF1 and FFF3. So if I step over FFF5, F7, F9, FB, FD, FFFF. Now timer 0 in mode 1, the maximum permissible value is FFFF. After that it will overflow and set the overflow flag. Let us see whether that happens. Okay, it has overflowed and it has set to 0001. Why it is 0001? Because this JNB instruction takes 2 machine cycle. Okay, and at the same time it has set the overflow flag. Okay, so and then subsequently we are clearing the run flag and clear flag. Okay, these 2 instructions are not exactly mandatory, but it is called as a best practice. Okay, so that is about the working of the timer in mode 1. Okay, now let us go back and show how the timer works in mode 2. Okay, so I will use the same code. Okay, now I will go back to this. When the timer 0 is in mode 2, M1 has to be set to 1 and M0 has to be set to 0. So the value of TMOD is going to be 0x20. Okay, so we will set that in the program. So timer mode is going to be assigned with 0x02. Now let us set the value of H0 as 0xF0 and TL0 arbitrarily as 0xF0. So the timer in mode 2 is an 8-bit mode. So the TL0 increments by a factor, okay, that is decided by the instruction, looping instruction, and once it reaches FF, it will overflow to 00 and then it will be auto reloaded to the value that is set in TH0. So let us see whether that happens. So I am going to build this particular program. Okay, so there are no errors. Okay, so now I'll go to the debug mode. Okay, so by default when the program has not executed, TMOD is 00, so timer is in 13-bit mode. Now when I step over, so TMOD is assigned to 0x02, that is 8-bit auto reload mode. Okay, so I step over, TH0 and TL0 will be set to F0 and F0. Now the timer is not yet running. When I step over, the timer starts running. So if you pay attention, TL0 has started incrementing. F1, F3, F5, F7, okay, and F9, FB, FD, FF. Now the timer in mode 2 has reached the maximum possible value of x 0xFF. So then it will overflow and it will be loaded with TH0. Okay, so let us see again what happens. Okay, so if you see here, it has overflown. At the same time, it has changed from FF to F1. Why is it? Because when it overflows, it will be loaded with F0, and this particular JNB takes 2 machine cycles, so it has incremented by a factor of 1. Okay, at the same time, if you see, the overflow flag is set. Now subsequently we are clearing the timer run flag and timer overflow flag. So that is about the timer in mode 2.